for sine squared x. Yes, you could do that. You'll be doubling an angle, won't you? When you do that, you create a 2x inside the trig function, don't you? Like, say again what you were asking. Okay, so which one? The cosine squared one? Just read the one that you were, because I want to explain why you wouldn't. Hmm? That's what I'm saying. It becomes a cosine 2x. There's a 2x inside the cosine when you use that identity. And none of your other trig functions have a 2x inside of them. Right? Your sine squared doesn't have a 2x. Your sine x doesn't. How about this? I'm just going to go for something here. What did I do? Replaced cosine squared x with the Pythagorean identity. I took the identity sine squared x plus cosine squared x equals 1, and I solved for cosine squared x, which means you move the sine squared to the other side of the equation. And what does that allow me to get here? And why would I do that? What am I going to gain by doing this? 2 sine squared x, right? Plus sine x plus 1 equals 0. What type of equation is this? If you squint your eyes hard enough, that's a quadratic equation we'd say a quadratic equation in sine. In other words, if I look at the sine x as being like a variable, I have like 2u squared plus u plus 1. It should be minus, it should be minus 1. Sorry, I forgot the sign on that. Y'all see what I'm saying? That kind of looks like 2u squared plus u minus 1 equals 0. It's like a quadratic form. So it can factor to be 2 sine x times sine x, let's see here, plus 1 here and minus 1 there. Does that work? Is that the correct factoring of that? Yes? So that's pre-cal stuff, trigonometric equations. Set them both equal to 0. 2 sine x minus 1 equals 0. Sine x plus 1 equals 0. Sine x equals 1/2. Sine x equals -1. So now I'm going to go to my unit circle and ask myself some questions. At what angle is sine x equal to 1/2? So when is the y coordinate 1/2? Those two spots, right? Pi over 6 and 5 pi over 6. Where is the y coordinate -1? 3 pi over 2, right? So we set up a number line. We put this in order. pi over 6, 5 pi over 6, and 3 pi over 2. Whoa, whoa. Remember that we are looking between 0 and 2 pi. So our test points need to be in there also. I'm supposed to plug these into the second derivative, right? Does anyone have any questions? I know I'm moving kind of quick through this. Anyone have any questions? No? It's a lot, right? Now, I have some options here. I'm supposed to pick an angle to the left of pi over 6. That means I need to pick an angle somewhere in here. And we don't really know any other angles like off the top of our head smaller than pi over 6. Like our unit circle, the smallest one is pi over 6. So let's think this through instead. Let's try and think it through. I don't know if this is going to work. I'm just going to pick a point over here. How about, and I don't think there's any way we're going to be able to do it without plugging in. Let's just try this angle right here. Let's just try this without plugging in. I'm going to plug it in to this. I'm boxing it right now. I'm going to plug it into this because that's the second derivative factored, isn't it? Let me just plug in there real quick. If I say sine of whatever that green dot is that bigger than a half or smaller than a half? Because what was sine here at this blue dot? What was sine there? It was a half, right? So if it's below that, the y-coordinate is smaller, right? So what would 2 times a number smaller than a half be? Bigger than 1, wouldn't it? Is this too much? Am I pushing too far here? I think I might be. Y'all give me no indication of where y'all are at all. Silence, yeah, silence means you all understand, right? The y-coordinate, look, didn't we say the y-coordinate right here was 1/2? On the right side of that circle, it was 1/2, wasn't it? So this, if we pick an angle smaller, that number is going to be smaller than a half, isn't it? Let's say like 1/3. I'm just giving an example. So if I then come over here and I plug in right here, 2 times 1/3 would be 2/3, right? Subtract 1 from that and you get negative, wouldn't you? So it will be a negative number. Okay? It's a negative number. Now, what's sine of x here? We said it would be maybe 1/3, smaller than a half. Plus 1 would be 1/3 plus 1. It's a positive number. So what is a negative number times a positive number? Negative. You see, I'm doing that without even plugging anything in, technically. I can tell you it's going to be negative. Now, what that means is it's concave down over here. Now, what would you do if you couldn't do this? Just get your calculator out. Make sure you're in degree or radian mode, whichever you want, and plug into this the second derivative, which is up here. So maybe you put in degree mode and you plug in like 10 degrees, something smaller than 30. Okay, I need a number between pi over 6 and 5 pi over 6. There's a good one right here. Right at the top, pi over 2. Right? So what is sine of pi over 2? 1. So plug into that same one that I have boxed there. What's 2 times 1? 2 minus 1 is 1. So that first box over here, this first thing is a 1. Right? That's a 1. And then plug in over here, what's this going to be? 2. So 1 times 2 is 2. So it's positive. What does that mean? Concave up. Then it's going to go down. And then it's going to go up. I'm not showing those. I'm just leaving it to you. So where are the intervals where I'm... Did we even do that earlier? You could do all the intervals, though, now? I mean, at this point, all the information's there, right? All you have to do is say it's concave up between pi over 6 and 5 pi over 6, unioned 3 pi over 2 to 2 pi, concave down from 0 to pi over 6, union 5 pi over 6 to 3 pi over 2. Do we have inflection points? Where are they? Pi over 6, 5 pi over 6, 3 pi over 2, right? Okay. I wanted to do that problem just to show you the sort of trig stuff you can run into. What did we have here? Cosine x squared minus 2 sine x there's the function. What is 2 times pi? About what? 6.2, 6 point something, right? So if you just look at this function, just between 0 and 2 pi, which is about out here somewhere, we had a local max, or sorry, a local minimum where? What was our answer for local minimum? Pi over 2, look at this. Pi over 2, there it is, lowest point. Where do we have a max? 3 pi over 2, here it is, right? Okay, where did we have inflection points? Pi over 6, right here is an inflection point. 5 pi over 6, there's the other inflection point. Where was the other one? Where? 3 pi over 2, right here. Oh, you know what? Hold on a second. We're concave down, concave down. Oh, we went from frown to frown. You know how I just put this right here? This is wrong. Look, I made a mistake. You can mark it. Look, right here, this should not have switched. It would have been frown, frown. Then 3 pi over 2 is not a point of inflection. So you can feel free to do something like this at home. Graph it, see if it matches your answers, you know, or even on a test. All right, we're going to put this, I think we're going to put this behind us. Now we're going to put it behind us, but in no way are we done. We're just moving to the next section, which is basically this with a little more added onto it. Yes?